Hey guys, good morning. So today we're going to be talking about gas laws. Gas laws deal with the relationship between four variables. Okay, the four variables are pressure, volume, temperature, and moles of gas. Okay, so when we think about pressure, pressure is the force exerted by a gas. Okay, and pressure um, is basically force, and force is a push or pull. You can think of pressure as a push, or force as a push or pull. Pressure is when the gas is inside a container, or even when it's not inside a container. The gas particles have kinetic energy, they're moving, and they have mass, right? So as they're moving and as they have mass, as they hit into things and they knock into things, they're causing a force. They're pushing on that object, and that is what pressure is. Okay, so gas particles, there's trillions and trillions and trillions of little gas particles. Yeah, they're really little, but they're moving pretty fast. So if you add up all the force, if you add up all those collisions, that is pressure, okay, of the gas. Okay, I know pressure is a little bit hard for some people to understand sometimes when it comes to gas. So we can talk more about that later. Okay, volume. Volume is just the space occupied by the gas. Okay. Temperature is obviously the average kinetic energy of the gas, or basically the average speed and the average energy of the gas particles. And then finally, moles of gas. So when we talk about gas laws, we're going to be talking about these four variables and how they're related to one another. Right? And the the assignment for today deals with these two worksheets over here. So simple gas experiments. And after simple gas experiments, there's just some situations that are described here. And you have to tell me what's going to happen in those situations. Okay, so we're looking at how the four variables are related. Okay, in the simple gas experiments worksheet here, in this one, there's always going to be two variables that change, while two stay constant, or they don't change. Okay, so you're going to have to identify all four variables, okay? And you're going to identify which ones stay constant, which ones don't change, and then which ones do change. And then tell me how they change. How are they related? Okay, how are they related? So you're going to look over this. Typically in class, if we were in class, we'd actually do these experiments. However, we're not in class, so um, you just have to kind of look at the situations and think about what's happening or what's going on, and then describe what two variables are changing and what two values are staying constant. And then when you talk about the variables, how are they related? Are they directly related? So if they're directly, then they both, one goes up, the other goes up. One goes down, the other goes down. That's if they're directly related. If they're inversely related, one goes up, the other goes down. One goes down, the other goes up. Okay. So direct means that they change the same way. Inverse means they change in opposite ways. Okay. So that's what you're going to try and figure out there. Okay. The other part here, very similar kind of situation here. There's going to be two variables that change and two that stay constant. And then you have to tell me what's going to happen and describe and tell me why. Okay, so you read these over and figure them out as best you can. They're tricky. They're tricky. So just think, 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 think. Okay. Now let's talk a little bit about the relationship between these four variables here. So P, V, T, and N. Okay. We're really not. I'm not going to talk about N today in terms of formulas, but I am going to talk about the other three in terms of some gas laws that there are. Okay. Um, so really quickly, uh, there's four laws we're going to talk about today, and then we'll talk about the other three on another time. Okay. The first one we're going to talk about is Boyle's law. Boyle's law relates pressure and volume. Charles' law relates volume and temperature. Gay-Lussac's relates pressure and temperature. And then the combined gas law combines all of the above. So Boyle's, Charles, Gay-Lussac's. We're just going to talk about those today. And then really quickly. And then we'll talk tomorrow. We'll talk more about how to actually calculate these things. Okay, so we're not actually going to calculate anything today. We'll do the calculations tomorrow. We're just trying to get the concepts down today. So first, Boyle's law. If you decrease volume, you increase the number of collisions. Therefore, you're going to increase pressure. Okay, so Boyle's law shows that pressure and volume, are inversely related. So P and V are inversely related. Okay, as you decrease the volume, pressure goes up. So here we have original pressure of 100 millimeters of mercury. The volume is 1 liter. We half the volume, we double the pressure. Okay, so we half the volume, then the pressure is going to go up 2 times. So the inverse of 1/2 is 2. See how that works? Pressure goes down 1/2 or decreases by 1/2. Pressure goes up to the inverse of that, or 2 times. Okay, so P and V are inversely related. That's what Boyle's law says. Okay, the next one, Charles' law, volume and temperature. So Charles' law says that volume and temperature are directly related. So if we decrease volume, so volume goes down, temperature should go down. Sorry. Yeah, temperature should go down. Okay. If you increase volume, temperature goes up. Okay. Really, I don't think of it this way. Actually, I don't think of it volume first. I think of it temperature first. So if temperature goes up, what's going to happen if you want to keep the pressure and number of moles the same? So these are constant here. I should state that in the other thing too. So pressure and number of moles are constant here. Okay. As temperature goes up, volume is going to go up. So it's going to expand. It's going to get bigger. Okay. I should have stated that here too. And here, P and V are changing. That means N and T are constant. They are not changing. So number of moles of gas and the temperature are staying the same. Then pressure and volume are inversely related. Okay. So it's important that I mentioned that. I forgot to mention that 2 variables here are staying constant, 2 are changing. Okay, for all of these laws. Okay, so here volume and temperature are changing, and therefore pressure and number of moles are staying the same. Okay, so as temperature goes up, volume goes up. As temperature goes up, it's going to expand. It's going to get bigger. Okay, if pressure and moles stay the same. Okay, the last one is that Gay-Lussac's law. Oh, did I say they're directly? Oh, yeah, they're inversely. Okay. Too early in the morning here. Okay. So here for Gay-Lussac's law, pressure and temperature are directly related. So if we keep the number of moles and the volume constant, so we're keeping these 2 things constant, number of moles and the volume, they're constant. So number of moles of gas is just how much gas do you have? How much gas do you have in like the number of particles of gas? That's when we're talking about number of moles. The number of particles of gas are staying the same. Okay. And volume is staying the same, so we're not allowing it to expand or contract. What happens is as pressure goes up, temperature goes down, basically. So I'm sorry. They're directly related. What am I thinking here? As pressure goes up, temperature goes up. That makes a lot more sense. It's way too early in the morning here. They're directly related. One goes up, the other goes up. So you increase the pressure, you squish something, you make it tight, you make it smaller, you squish it, the temperature is going to go up. Okay, it really helps to actually think about it oppositely. If you increase the temperature of something, the pressure goes up. Right? If you take a can that's closed and you throw it on a fire, it's not a good idea. It's going to explode. It's going to explode. As temperature goes up, pressure goes up. Right? Temperature goes up, pressure goes up. Or in other words, as temperature goes down, pressure goes down. Okay, you'll see that like if you cool something too, if you cool it down, it'll shrink. If it's not allowed to shrink, so here we're not allowing it to shrink, then the pressure is going to go down. Okay, the pressure is going to go down. Okay, so these are directly related. One goes up, the other goes up. One goes down, the other goes down. Okay, and then the combined gas law. This one we're not going to worry about too much today, but this one, the only thing that's constant here is the number of moles is constant. The number of moles is constant. Pressure, volume, temperature are all changing, and they change in this way here. P1 V1 over T1 equals P2 V2 over T2. And the reason I say this is the only really one you need to memorize is because if you keep temperature the same, if we keep temperature constant, then we get P1 V1 over T1. Oh, sorry, P1 V1 equals P2 V2, which is Boyle's law, right? So we get Boyle's law, and according to Boyle's law, we keep temperature constant. Okay. If we keep, let's say, volume constant, that means those two are the same. We can't kind of ignore them. We get P1 over T1 equals P2 over T2, which is Gay-Lussac's law, right? And if we keep pressure constant, we can ignore pressure here. And now we get V1 over T1 equals V2 over T2, which is Charles' law. Pretty cool how that works, right? That's the only way you really need to memorize. Okay. So you're looking at these three laws today, this one, this one, this one, to explain a lot of these ideas here. And just the relationship, just think about the relationship between the two variables. Just think closely and think carefully about what's going on. If we hold two of the variables constant, so think about which two are remaining constant and which two are changing. And then as one changes, how does the other one change? Okay, and that's what you're thinking about today in these problems that I gave you. All right. And we'll discuss a lot of these tomorrow, and then we'll also talk about using math to solve for all these laws here, the Boyle's, Charles, Gay-Lussac's, and combined. Okay, and that's what we're going to be doing tomorrow. All right, good luck with that, and we'll talk about it more tomorrow. And yeah, that's about it.